Good evening. My name is Chris, and I'm going to be taking you through a brief layman's introduction to the concept of GIS, also known as Geographic Information Systems. This is not a specifically scientific introduction, but it is so that anybody can understand what GIS is, and also in later videos I'll explain how to use Geographic Information Systems for analysis for anyone ranging from a social scientist to a hardcore scientist for that matter. So what is GIS? It's also known as Geographic Information Systems or Geographic Information Science. So let's break this up. Geographic information, what is it? Basically, it's information about places and the Earth's surface. It's knowledge about what it is, where it is, and when it is. All of these things are important in GIS, especially the when becomes important, as data becomes redundant very quickly. So, the systems. The systems refers to the software and the hardware that drives GIS basically, and the science refers to the creation of the concepts and theories that drive the software. Another definition, a bit more complicated, as you'll see, according to Briggs, is GIS is a system of integrated computer-based tools for end-to-end processing, capturing, storage, retrieval, analysis, and display of data using location on the Earth's surface for interrelation in support of operations management, decision-making, and science. You can also go look at the story of Dr. Snow, which I won't be talking about right now, but it's very interesting for GIS and spatial thinking, which we'll get to. So, spatial thinking and GIS. Let's start off with saying GIS is not magic. It starts with spatial thinking. GIS does not start on a computer. It is basically you thinking about the environment and around you, conceptualizing a problem, methods to solve this problem, and then working through these problems with a PC to get to your answer. Basically, why would you use GIS instead of just doing it on paper or manually? It's because these things can become complex, and computers just do a lot of things faster once they're given the right instructions. But we'll get back to that in a moment. So, spatial thinking, another complex definition. Spatial thinking is thinking that finds meaning in the shape, size, orientation, location, direction, or trajectory of objects, processes, or phenomena, or the relative positions in space of multiple objects, processes, or phenomena. Spatial thinking uses the properties of space as a vehicle for structuring problems, for finding answers, and for expressing solutions. It is basically about finding meaning and relationship between features based on their spatial component, such as why did the chicken cross the road? Because it was raining on his side. Could be, but it's basically about thinking about things around you, the environment, and the interactions that one thing may have on another. So that is basically an element of spatial thinking, at least. So let's get to solving a basic problem with GIS. Just an example. So let's say you want to buy a house. So you want to know a few things before you decide to buy this house. You have a specific budget in mind. Do you want to live close to a mountain, a beach, or do you want to live close to both? Is it close to my work? Is it close to schools for kids I might have? And finally, how safe is this area? Now, to get all of these things right, it is no easy task. But as I'll show you in a moment, GIS can help this process along. And this is basically what GIS does, is it takes your problem, you basically have to envision the variables, input them, and it will give an output to you much quicker than you could do by yourself. So let's look at a little bit of an example I drew on paper deliberately to show that GIS starts with spatial thinking and then a solution can be driven. So I would say you'd need about 5 layers, but let's start off with, so this house needs to be close to a beach and mountains, needs to be close to schools, close to your work, and affordable. So over here we have some mountains right on top. On the bottom right and left corners you'll have a bit of a beach, as you can see by the legend on the right. Then we have these little things with the S in for schools, and W is your work. These little cash bars say that area is way too expensive, and these straight line skew lines indicate that this area is not very safe. So basically you'd feed all of these data sets to your GIS, and it will within moments come up with a solution telling you that right here in the center towards the right is this area that satisfies all your needs. It is safe, it's affordable, it's close to a school, as you can see, and it's affordable, and it has a beach and your mountains. So that would be the prime example of a simple site selection done by GIS. This can be expanded to a country, to the whole continent for that matter. But basically this is GIS. You have your problem, you have your solutions, ideas, you feed this information to a GIS and it returns a solution to you basically. So let's just step a bit back. We all already use GIS on a frequent basis. Google Maps, Google Earth, especially those of you that play around with Google Earth. That is a basic GIS system. Your GPS, whether you use your cell phone or a dedicated GPS, and even your sports watch with GPS capability is also a GIS using tool. So what other things can GIS do? Site selection, as we just looked at. It can be for marketing, for building, anything. For testing relationships between things, such as if it's why is it hot in this area but not in the area next to it. You might find that there's something in between, such as a mountain. And it also boils down from Tobler's first law of geography that states everything is related to everything else, but near things are more related than distant things, which basically just hints towards everything has a relationship, and we can use GIS to discover these relationships, so to speak. It can be used for route planning, even for your holiday. You might work out the most effective route to take, the cheapest route, the most scenic route, as well as things such as change analysis, such as in 1980s, what did this area look like? Today, what does it look like today? You can use GIS to check, did the population grow? Did what expanded? Was it housing? Was it industrial areas? Basically that kind of thing. So finally, does it cost money? Well, you have yes and no. You can use free software such as QGIS, which is completely free, and as in free beer. It's basically as powerful as any proprietary software. You can also use ArcMap, which is proprietary. It costs a fortune. So for people that just starting out, I would suggest QGIS. Data used, you can get freely available data such as Landsat satellite data. Governments hand out free data quite frequently as well. And then you get proprietary and protected data, which might cost a bit more. Thank you very much for watching my first small video. I hope I taught you guys anything, and you can check down at the bottom for the link to this presentation as well as my contact details. Thanks.